All right, guys, so we're back with another problem that one of the students sent via the e-learning. So this is another one of those molar mass problems, and we're given a couple pieces of information that we need to utilize before we actually start the problem, right? So what is the number of chromium atoms, right? That's what the question is asking for, just chromium atoms, right? And it's given us 78.82 grams of potassium dichromate. And so now one of the things that I've told you guys to memorize for your exams is some of these polyatomics and things like dichromate, right? You kind of want to know what that is for your exam. So I'll tell you what it is right now, right? K2Cr2O7. And so you'll not only see potassium dichromate, but you'll also see things like Na2Cr2O7, which is just sodium dichromate, right? So it's dichromate and the respective element in front of it, right? So if we know that potassium dichromate is K2Cr2O7, then what we really need to do from here is we need to find what the molecular mass of potassium dichromate is, right? And so what I would do is take each of these elements, right, and find what their molar masses are, right? So K is 39.09, Cr is 51.9. 9, and oxygen is obviously just like 16, right? So we can use that. So what I would do here is 39.09 times 2 plus 51.99 times 2. And then how many oxygens do we have? 7. So it's just going to be 16 point something like that. Right? And so obviously my math isn't going to be exact. I'm just kind of skipping around, but we know that the molecular mass ends up being about 294.2, right? So with that, we know what the molecular mass of potassium dichromate is. And so now what can we do? We can find the moles, right? So if there's 78.82 grams, right, we have that. And then there's, in 1 mole, we found this, right? It's 294.2 grams. We know that there is about 0.2680 moles of K2Cr2O7. And now from moles, right, how do we get to atoms? We did this very early on, right? Avogadro's number. Think Avogadro's number, right? So I'll set up a longer equation for you guys. So if 2680 mole K2Cr2O7, right, over 1 times, it's a little messy, but you'll just have to 6.022 times 10 the atoms per mole times, right? And now this is the kicker, right? We need to find just chromium atoms, right? Not anything else, right? So what you would do here is 2Cr for every 1 K2Cr2O7. Now, if you end up computing that, you'll end up getting something like 3.228 times 10 to the 23rd. Now, that's going to be your final answer. Atoms of Cr. And so let's look back in the answer choices. This is the most similar, right? It's not going to be exact, but the beauty of this is that it's multiple choice, and you know that whatever one is the closest is probably going to be your answer choice. So everyone follows, right? You know how to convert from moles to atoms, but you have to make sure that you're only getting the chromium, right? So if there's 2 chromium per every potassium dichromate, you have to do times 2, right? Same way we do combustion, right? If there's 2 hydrogens for every water, right, you have to multiply by 2. So that's how we get to 3.227.